Getting ready for our quarter 3 test tomorrow. So what we have is a GCF here. That's the only type of factoring we're doing. So we can take a 5 and then one of each variable type out. So what we're going to have on the inside then is 2y to the 5th power. I'm sorry, messed that up there. Let me back it up. 2y to the 5th power, and then we're going to have a z squared. And then we're going to have plus 5x to the 4th power y z cubed, and then minus 6, actually x to the 7th power. Don't need a y and don't need a z. All right, so what we have here is we got to make sure we can distribute back and get the original problem. On number 2, we're trying to stress to you that you're going to look for a GCF first all the time. So I'm going to take that 2 out of this problem, and 2x squared plus 2x minus 24. You will not get the correct factorization if you don't pull the 2 out first. So now that we have the 2 out first, we got to leave it along for the ride, and we're going to look to factor this trinomial. So since there's leading term of 1, we're going to have x and x, factors of 24 to get us to 2. You can guess and check, but you know you're going to have a plus and you're going to have a minus because of this minus right here. And then the factors of 24 that are real close together are 6 and 4. And those actually are the two that end up working here. Now remember, you want to do your outside and your inside to see if that works. So since we have negative 4x and positive 6x, that does combine to the 2x's that we would want right here. Don't look at the original problem, look right here. So the final answer to this would be this here. If it didn't work out, we'd want to move things around, switch the 4 and the 6, maybe try factors of 12 and 2 or 1 and 24, but try to find those factors. Okay, number 3, same thing, but I'm going quicker because there's no GCF here. I just have the a squared. So I know I'm going to have an a and an a. This minus right here tells me there's going to be a plus and there's going to be a minus. And then factors of 21 are 3 and 7. And I want to look ahead and see that I want to get a negative 4b. So I'm going to put a negative 7b here and then the positive 3b over here. So again, when I check the outside, that would be negative 7ab. Inside positive 3ab combines to the negative 4ab. So that would be the factored version. Difference of squares, we seem to be doing a better job at. Recognition is the key. And I simply get 4x plus 7 and 4x minus 7. Those square roots are where we get those terms from. Now just notice if you were to FOIL this, the outside and the inside terms cancel off, and we get just the 2 terms there. Now this is the one we got to slow down in SDAP, yo. The SDAP is just for the signage. Okay, so you do have to recognize that it's a sum of cubes. So that's going to be a binomial times a trinomial. And we're going to SDAP, yo. So that means same, different, always positive. Take the cube root of this and we get x. Take that value and square it and we get x squared right there. The cube root of 64 is actually 4. It's not 8. That's the square root of 64. So that goes here. Then when you take that value and square it, you get the 16 here. And then what is left, you take the product of those two. That means multiplication. So you're going to have a 4 times the x. If you didn't understand this completely, rewind the video and keep watching this problem until you see how the progression is made. Hopefully you'll notice that there is this one going here and here, and then we have, let me grab the other highlighter here, the back end goes here and there. And then how do we get this term here? We take the product of the blue and the green there. Okay? All right, moving along here. Recognizing on number 6 that hopefully you're not going to be confused on where to start. You're just factoring, even though it's an equal 0. So really what you're going to do is you're going to solve by factoring this problem. And we did this one so many times when we were learning this chapter. So I'm going to have a 2x and I'm going to have an x. All right? Well, my signs are going to be 1 plus and 1 minus. So we're going to have to figure out which one goes where. And then factors of 15 could be 5 or 3. So I'm just going to try this because this is me, I don't know, just thinking about the problem. If I try this here, I have a positive 5 and negative 3. When I do outside and I do inside, I can see that those are not going to work. Like -6, +5 does not get me there. So I want to try something different. So maybe instead of the 5 and the 3 that way, what happens if I put a 3 here and a -5 there? Well, if I do that, I have -10x on the outside, +3x on the inside. That does work out. So that, on the last problems, we would say, okay, we're done, but we're solving. So right now, what do we have? Right now, we've got something. Oops, sorry. We've got something times something gives me 0. One of those two things must be 0. Okay, so I'm going to take this 2x plus 3 and I'm going to say, hey, that could be one of the items that gets me 0. Or this second one here could be 0. So, or x minus 5 equals 0. Well, I'm going to solve each of these now. Subtract 3 from both sides. 2x is equal to -3. And then divide by 2 to both sides, so x equals -3 halves. Or, when I add 5 to both sides, x equals 5. So those are my two possible answers to this problem. And when we see that quadratic up there, that's when we should start thinking that there could be two answers to a problem. All right, looking here, find domain of the given function. I'm not even looking at the numerator when they're talking domain. I'm only looking at the denominator. First thing I want to do is try to factor it. That is a simple difference of squares. So x plus 4, x minus 4. And what we're looking at here is to see if we could actually find values that would make 0. And then we're going to say we can't have those values because we're not allowed to have 0 in the denominator here. All right, so here -4, here +4 is actually the two values we cannot have. So x cannot be -4 and x cannot be 4. Those are the two answers we're looking for when it asks for domain. All right, moving along, this one here, you want to simplify by factoring. So you want to first take a GCF out of the top. So that's going to be your y value, y onto x minus 3. And then the denominator, again, looking at this, we have to factor. A good chance when you do these that you're going to come up with a factor out of the two that actually is something we can cancel off. Doesn't work every time. But if that was x minus 3, then I would have a 4x here. I would have to have a plus because the signs would have to be different. And then the factors of 3 are 3 and 1. So looking here, if I actually FOIL this out, I get positive 1x, negative 12. It does combine to that middle term. So this does work out like that. So the final answer to this problem would be y over 4x plus 1. Done and done. Over here, you got 3 big GCFs here. So we can take a 3 out of the first. So that's going to be 3 times 3x minus 4. And in the denominator here, we're going to be able to take not a 3 out, but a 2 out. And that's on to 3x minus 4. Convenient. Times, and then we're going to take a 5 out, and that would be times x plus 2. And this would be all over. No GCF, so we have to try to factor. All right, so 3x squared tells me I'm going to have a 3x. And I'm going to have an x. Good chance that these might match up is what I'm thinking. So I'm going to try the positive 2 here and the -4 right there. And that is the correct factorization. Now, it's tough for me to say that quickly. I know it takes some of you longer to factor, but go through your factoring procedure for trinomials, and that's what you'll get. Now, noticing this, we can cancel these two. One of the 3x minus 4s has to stay on the bottom. The x plus 2's do cancel. I don't have anything I can cancel more on the top, so this is actually going to be 15 in the numerator, and then the denominator 2 times parenthesis 3x minus 4. All right, moving on to division now. Division is the same as, you guessed it, folks, multiplying by the reciprocal. Now, that does not mean you change the first fraction. I am going to show my work by actually factoring first. That is a good idea. So x plus 3x minus 3 times, and then I'm going to flip this fraction. So I'm actually going to have x plus 3 on top, and then I'm going to have 15x cubed on the bottom. Well, after we flipped it, we see some things cancel off. 5 goes into 5 once, 5 goes into 15 3 times. X cubed and x to the fourth actually is top heavy by 1x. So the only thing left on top is an x. And then on the bottom, what do we have? 3 parenthesis x minus 3. All right, so that'd be our final answer. I'm going to cut this video off here, so we have a part 1 and a part 2. There's a major transition that happens once we start going into subtraction and addition. Notice we did not need a common denominator for those problems. We will, starting with 11. Okay, so I'll pick up in a minute on a second video.